Hello, I'm Brian Farrell, and welcome to PACE IT session on Introduction to IPv4 Part 2. Today we're going to be talking about public versus private IP addresses, and then I'm going to talk about automatic private Internet Protocol addressing. There's a fair amount of material to cover, so let's go ahead and begin this session. So let's start by discussing some of the differences between public and private IP addresses. Now, because of its structure, IPv4 gives us over 4 billion possible addresses, and all IPv4 addresses need to be unique on their network. So without some special mechanisms in place, all IPv4 addresses would be public addresses. Now, public addresses are routable, meaning that they can traverse the internet. Each public IP address is unique on the network. That means it's unique on the internet. If all IPv4 addresses were public, the IPv4 address pool would have run out long ago. So they developed some special mechanisms to help conserve that pool. And that particular mechanism that conserves the pool is private IPv4 addressing. Private addresses are non-routable, meaning the address cannot pass through a router's interface. Private IPv4 addresses are only relevant to their own local network. So now let's talk about how we get those private IPv4 addresses. There are three main pools of private IPv4 addresses. The network administrator is responsible for determining which of those pools is used on the local network. So now let's talk about those three pools of private IPv4 addresses. First up, there's 10.0.0.0 up to 10.255.255.255. Now you can use this with a minimum subnet mask of 8 bits. By default, it provides a single Class A network with over 16 million host addresses. The second pool that's available is 172.16.0.0 up to 172.31.255.255. Now this can be used with a minimum subnet mask of 12 bits. By default, it provides 16 Class B networks with over 1 million host addresses available in each network. And then the final pool is 192.168.0.0 up through 192.168.255.255. Now this can be used with a minimum subnet mask of 16 bits. By default, it provides 256 Class C networks with 65,536 addresses available for hosts. And there you have the three pools of private IP addresses that are available in IPv4. These have extended the life and usefulness of IPv4 for years. Now let's move on to automatic private Internet Protocol addressing. Now, before I get into a PIPA, we need to talk about methods of assigning IP addresses. There are three main methods to do this. Manually, the network administrator assigns each host with its own address. The second method is automatically from a service, specifically Dynamic Host Configuration Protocol, DHCP. A DHCP server is configured with all of the information needed for a network host to join a specific network. And finally, we have automatic private Internet Protocol addressing. This is where the host automatically assigns its own IPv4 address using a PIPA. It self-selects its address. So let's talk about this address. The PIPA address pool ranges from 169.254.0.1 up through 169.254.255.254. The PIPA address can also be called a link local address. Hosts that receive these addresses can only communicate with other hosts who have PIPA addresses. When an PIPA configuration appears in IPv4, that usually denotes a failure or a misconfiguration. That would be a failure of your DHCP service or a misconfiguration that caused two hosts to have the same IPv4 address, in which case the second host to join the network will assign itself an IPIPA address. Now that concludes this session on Introduction to IPv4 Part 2. We talked about the difference between public and private IP addresses, and then we talked about automatic private Internet Protocol addressing. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon.